Good evening or good day. Thank you very much for the invitation to present some of our results, what we're doing here in Germany and Europe on the decarbonization of the steel industry. I am Marlene Arens and I am a senior researcher at Fraunhofer ISI. So it's an Institute for Systems and Innovation Research in Germany. The past 2 years, I was a postdoctoral fellow at Lund University in Sweden, and I was attached to the hybrid project, which aims to produce steel using renewable hydrogen. So thinking about today's speech, I would like to give a brief overview on how to decarbonize the steel industry and what are the key issues. And I'm very happy to see that many of those things I will touch upon as well have been mentioned today. So maybe some things I see a bit differently, but we can check on that. So the outline of my presentation is that I will look briefly on the yes production, then I will look at alternatives to coal for steel production. This is a bit catchy title, the challenge I call it. So we look at the ground of steel mill, and then I will present 3 technologies, and I will briefly discuss those technologies, and then I will draw some conclusions. What I want to point out here is that the US steel industry has a high share of scrap-based steel making, which is this green slide. So 2/3 of your production is based on electricity and scrap. You have a small share of natural gas-based steel making, and you have like a quarter or 1/3 of it is based on coal. And when it comes to decarbonizing industry, this is where you should work on the coal-based CO2 emissions. So on the next slide, so now maybe it's a bit small for all of you, but the basic takeaway from this is, and you have seen some of those chemical reactions already, is that that the steel industry decarbonization issue is not only about providing heat, but that it's about a chemical reaction, just as the other presentators have said as well. So currently you use coal to get the oxygen from the iron ore, and then you have iron and you have carbon dioxide. So that's the source of your CO2 emissions. And what you can do is that you can replace the carbon with hydrogen, and then instead of getting carbon dioxide, you get water. And a third option would be, instead of using carbon or hydrogen, you could use electricity. And then you would get oxygen and iron. And the final one is, of course, that you stick with the carbon and with the coal. And instead of releasing the carbon dioxide into the atmosphere, you capture it, and then you store it underground, or you make CCU. So this is this is an example steel site, and it shall give an impression of what challenges are out there when it comes to decarbonizing the steel industry. So this is a steel mill at IJmuiden. I just took this picture because it's the nicest one I could find of a steel plant. And we know that steel making is about using a blast furnace, which is here in the center. And you also need some other plants that prepare your raw materials that you can feed them to the blast furnace, which is the coke oven, which is over here. And then over here on the left side, you have the sinter plant as well. So these provide a prepared raw material of iron ore. And then you have steel making. And finally, you have rolling and finishing. And if you want to decarbonize the steel industry or coal-based steel making with blast furnaces, then you have to replace all of these assets. And as has been mentioned before, this is capital intensive. And if you replace it, you lose some part of your invested money. So that's one of the key issues. But from a technical perspective, it's to some extent possible. So here I mentioned those ones. The most prominent in Europe at the moment is hydrogen direct reduction. So you use natural gas-based facilities that are commercially available, and then you add hydrogen instead of natural gas, and then you would be basically CO2 free. You could also use the electrolysis, which is another device. And then other options are plasma smelting or carbon capture. And then, of course, what has not been mentioned so far as much during this during this evening event is demand reduction, of course. So every ton of steel that you do not produce does not emit any CO2 emissions. So now I ran through the three options. So the first one is gas-based direct reduction, or it's hydrogen-based direct reduction. As I mentioned, natural gas-based direct reduction is commercially available. So about 82 million tons of steel are produced in 2019. So it's a mature technology. And those plants that run on natural gas can be equipped with hydrogen. And I think the overall opinion about it is that it's feasible, and it's you need to make some minor changes, but that it's technically feasible and that there is not a major issue about it. And in Europe, as I mentioned, there is some focus on this technology. So I worked within the hybrid research project one. So in Sweden, they erected a pilot plant in Luleå, very up in the north of it. And they plan to build a demonstration plant as well, and then they also aim to sell fossil-free steel on a commercial scale by 2027. So in the next 7 years, they wanted to do that. So that's very ambitious. In Europe, there are other projects as well. For instance, the Salzgitter project from a steel company, which is called Salzgitter in Germany. They also are starting to build a pilot plant. There are plans from ThyssenKrupp and Dillinger on hydrogen direct reduction at their steel sites. And then ArcelorMittal announced to erect a demonstration hydrogen direct facility at their site in Hamburg in northern Germany, which will use the remaining hydrogen from their current Midrex plant, so from their current natural gas-based direct reduction facility, and they will feed a smaller demonstration plant with the off gas, so with the surplus hydrogen from the off gas. That are the plans in Europe. And then in Asia, for instance, I think Tenova announced that in November last year, so some 8 weeks ago, a Chinese steel company ordered a direct reduction facility that shall run on hydrogen of 0.6 million tons, so quite a large plant already that shall run on hydrogen. And then, as mentioned already as well, Baosteel announced carbon neutrality by 2050. So these are events that point into some direction. So there's some movement in it, but of course, there are many plans, and what is needed is that this comes into real investment and that it turns out to commercial plants at large scale. The second technology I want to briefly touch upon is electrolysis of iron ore. So instead of using coal or hydrogen, you use electricity, and then you can split the oxygen from the iron ore. From the European perspective, this is at a very early stage, and given that we have the Paris Agreement and that by 2050, the largest shares of the economy shall be carbon neutral, it's not that likely that this technology will play a major role, given that it's at an early stage, and then considering the diffusion rates and that it will take some time until such an innovation will diffuse through the steel industry. It's in Europe. It's under research with ArcelorMittal, but also in the US, there is another electrolysis, and they are different of their temperature. So one is a high temperature, and the other is a low temperature. But yeah, from European perspective, we do not expect much contribution to the steel production by 2050 from electrolysis. And then this is also another technology which is somehow discussed with some companies. So it's plasma smelting reduction. In Europe, it's followed by voestalpine, an Austrian steelmaker, which is quite innovative. However, this is also at a very early stage. It may be more energy efficient. So in this discussion of decarbonizing the industry, I think we should not forget that those processes also should be energy efficient. at some point. So this process may be more energy efficient because you can produce steel just in one step, so you would omit some heat losses. However, it's at early stage, so they planned an upscale from 100 gram to 50 kilogram batch process. Yeah, so at early stage, and it should be it should be followed how it evolves, and if it's a good opportunity to reduce CO2 emissions in the steel industry, it should be taken up, definitely. So with this, I also already come to my conclusions, what I think about decarbonizing the steel industry and further R&D needs. So from a technical point of view, hydrogen direct reduction for the steel industry is an available technology. I would say it's commercially available, and it's possible to do it. However, the problem is that the hydrogen is more expensive, and the steel industry would not have a business case to sell their steel, given that it's more expensive than competitors that would produce it from coal at the moment, as there is no global CO2 price. But a good starting point from a European perspective, but maybe also from the US perspective, would be to move from coal-based steelmaking to natural gas-based steelmaking. And once hydrogen will be available at cost-competitive prices, then a switch from natural gas to hydrogen would be no big issue, and you just could do it. So maybe using natural gas-based steelmaking as a bridge technology, that would be a second takeaway. Other technologies, as mentioned, there are other technologies, but they are at very early stage. So it's not really sure what their contribution could be by 2050. And then I had carbon capture on my list as well as a mitigation option, and it could play a role. However, from our perspective, we do not think that carbon capture will be a major technology for the steel industry, as there are other sectors which are even harder to abate than the steel industry. And from that perspective, maybe CCS will be, or carbon capture and storage, will be reserved to other sectors like the cement sector, which is even harder to abate, or as a means to generate negative emissions to outweigh those emissions from agriculture or from land use. Yeah, and then do not forget about material efficiency when you think about reducing CO2 emissions from energy-intensive industries. And then, yeah, the major barriers for decarbonizing the steel sector are the operational costs. And this aligns with the availability of low CO2 hydrogen. So if hydrogen would be cheaper, we had these presentations with $1 per kilogram, then it would be a business case and everything would be fine. But as long as hydrogen is more expensive, higher operational costs are the major barrier to the decarbonization of the steel industry. And then here, finally, I list some policies that are discussed in Europe that would address operational costs, which would be the generation of lead markets or quotas. Quotas would be that steel industries would have to produce a certain share of low carbon steel, or that steel consumers would have to use a certain share of low carbon steel. Other issues or other policies discussed are carbon contracts for difference. So this is a very the state would play a major role in the steel industry then, as the state would pay the difference would pay for the difference for the higher cost to the conventional steel. So they would pay the difference of the difference for the higher operational costs. And then also carbon border adjustments are discussed. So if there is an area in the world that produces steel at higher operational costs, in order to meet the Paris Agreement, there is the idea of having like a tax at the border to outweigh the higher prices for this low carbon steel making. These are all discussions at very early stage. But yeah, in Europe, we have the European emission trading system, which increases the cost for CO2 emissions. So we need to find a way out. And these are one of those thoughts. But that discussion, I think, in the US is a bit different. But the main takeaway is that operational costs at the moment are the main barrier to decarbonizing the steel industry. Yeah, and with that, I come to the end. Thank you very much for listening. And I think maybe if there are later some questions, I will be happy to answer them. Thank you.